Welcome back to the presentation room, all of you ATypI Tech Talks attendees. Our next presentation is going to be Yoon Park. Yoon is a designer and creative technologist from Seoul, Korea, and he is the principal UX designer at Microsoft's HoloLens. In this session, Yoon Park will share his personal journey on mixed reality and experiments with holographic type in physical space using Microsoft HoloLens. The presentation includes design guidelines for type in mixed reality and useful tools and resources for designers to get started in AR and VR. And before that, we will play a short video of gratitude to announce our sponsors, and then we'll go straight into the talk.
Hi everyone. In this session, I'd like to share my personal projects and experiments on type in mixed reality. My name is Yoon Park. I'm Principal UX Designer at Microsoft. I'm working at Mixed Reality Design and UX Research team. I originally studied electrical engineering and worked as a software engineer, but I went back to school to study graphic design because I was so into typography and graphical user interface. And I continued my study at Parsons for graduate school. So because of this mixed background, I have been designing and developing many apps for iOS and different platforms. And I joined Microsoft back in 2011. And for the first 4 or 5 years, I have been mostly focusing on 2D UX design, designing apps for Windows and Windows Phone and iOS and Android. Then I joined Mixed Reality Design team back in 2016, where I started my journey on mixed reality. So I have prepared 3 sections for today's talk. First, I'd like to share my journey on how I started exploring type in different media and technologies, and my personal projects and experiments on type in mixed reality. Then we will go through some of the design considerations for type and text in mixed reality. And lastly, I'd like to share some of the crucial spatial interactions and UI building blocks and useful tools for building mixed reality experiences. So for your information, today's content is based on my personal projects and experiments. So just wanted to let you know that the content does not represent Microsoft view or opinion. So let me start with my journey on mixed reality and type. So when I was a kid, I really enjoyed drawing things like mechanical things and robots, cities, but I really enjoyed drawing these logos of the companies. Especially, I really love the geometric shape of the computer companies from 90s. So I remember my textbook was always filled with these logo sketches. And even when I was working as a software engineer, I really loved these beautiful text displayed inside this graphical user interface. I didn't know about the terminology typography, but I really enjoyed just working with this type, and even I enjoyed customizing the typefaces in the code editor. So I decided to go back to school and study graphical design, and I really enjoyed the journey, learning all the historically important typefaces. And yeah, this was one of my projects I created with the Adobe Flash with a 3D engine, Paper Vision 3D. This kind of 3D timeline browser for historical types. Then I continued those kind of explorations of different media. And when I saw iPad, I thought it would be amazing to be able to interact with the type with this large screen and using your fingers directly touching beautiful typefaces. So this was my thesis project, Typography Insight. This is a kind of toolkit for learning and teaching typefaces. So as you can see, you can overlay or compare side by side historically important typefaces and understand their subtle differences, like a design of the serif or design of the apex, counters, and you can learn about terminologies and understand how the design of type had been evolved. So this is a kind of initial version, and I was able to introduce it and AIGA, and also started kind of receiving good responses from the community. And I'm still continuing this project as my side project and hobby. I've been kind of updating it to support the latest devices like iPad Pro or iPhone Pros on the kind of high resolutions or dark mode. Then when I joined Microsoft, I was able to continue my journey as a kind of designing the app. So I've been kind of designing these content consumption apps like sports and finance on Windows or iOS and different platforms. So yeah, I've been kind of designing and publishing many apps, and mostly they've been kind of 2D UX design. Then when I joined the mixed reality design team back in 2016, of course, the first question that I had was, how can I build something for mixed reality? So for those of you who are not familiar with the HoloLens, this is a kind of quick video that shows some of the capabilities. So basically, you can display the holographic object inside a physical space. It has a kind of see-through transparent lens, and through the laser, it displays these kind of holographic objects. And these holographic objects are kind of placed in the physical space just like a real-life object. So it can make it fixed. So if you walk around, it still stays there, very stable, just like a real-life object. So you can use it for data visualization and displaying, visualizing 3D data in physical space. There are a lot of interesting and exciting use cases. So when you look at this term mixed reality, it is nothing really new. So there's a kind of, there's an augmented reality which kind of mixes the digital information on top of a physical world around you. And there's a virtual reality which kind of displays and covers your entire eye with the digital information. For mixed reality, you can see it just as a kind of spectrum from this augmented reality to virtual reality. So it kind of covers all this spectrum. Then, because of the limited technology, currently we have a kind of different devices to experience these different spectrum. But I can imagine in the future, maybe you can have a single device to kind of experience entire this spectrum of mixed reality. So at Microsoft, have been kind of evolving this mixed reality technologies for a long time. It kind of starts from this Kinect sensor from Xbox, where it analyzes your body skeleton and use your entire body as an input for the games. Then this sensor has been evolved into this sensor for HoloLens, which kind of recognize the environment, and through the spatial mapping, you can place a digital object in the physical space. So the HoloLens 1, the first generation, was announced in 2016, and it has been evolved, and we have announced HoloLens 2 back in 2019. And it was kind of journey about making these kind of hardware with a ton of sensors, PCB boards, making it as a compact standalone computer, just like on the right side. So if you look at some of the practical examples that are actually used, so like it is used for designing the car, the Ford, overlaying the holographic design on top of the physical one. And NASA JPL, they're using HoloLens for designing the Mars rover, Perseverance rover that landed a few years ago. And you can use the HoloLens to see the design in one-on-one scale and looking inside the parts. And there are other examples like using HoloLens for designing the art staging the digital object to preview the scale and position. And it is also used by Toyota for kind of designing and maintaining the parts and designing the engine of the car. Then, good example of using in museum. This is a Mengxiang Michel model, overlaying the rich information on top of the physical model. And Thyssen Group has been using for a lot of elevator maintenance programs. And this one is an example of the AutoCAD using for 3D design on top of the physical object. And yeah, example of kind of home remodeling preview by Lowe's. And also, yeah, it's used by education field. This is an example of a Case Western Reserve University using for the medical class. And of course, it's good for kind of previewing 3D models and architectural model. This one is example by Trimble. So yeah, those are kind of some of the actual examples that have been kind of applied for different types of industry for the past several years. And so when I first joined HoloLens design team, of course, the first question that I had was, how can I build something for HoloLens? So yeah, based on my passion and interest in type, I started just by placing the type in physical space. Initially, I thought typography is not a relevant topic in 3D space, but I just wanted to try and feel it, how it looks like. And it turned out it was so beautiful and gorgeous, this holographic type in physical space. It's a little bit different from the captured video. This is the phone video capture through the HoloLens display. And as you can see, it feels like a very glowing light object, something like a neon. It feels quite magical. So I decided to do something with type. So I started sketching idea. I thought maybe I can create an app that can you can lay out type in physical space. Then I started learning Unity, started building basic UI with lots of trials and errors. Then also started learning about some of the basic spatial interaction patterns like a tag along and billboarding. And also, yeah, learned about the basic Unity components like a rigid body and animation triggers. Then I published this first version back in 2016. So it's a simple app. As you can see, you can grab and move and type in the space and layout. Then you can work around and look at them from different angle. And you can use the spatial mapping capability of HoloLens. So you can lay out on top of the physical surface like this. So I thought maybe this could be used for designing architectural signage because you can change the font and color in real time, and you can look at it from the different angle. And I also kind of tested out some of the educational content that I had in iPad version just to see if there's any benefit of having it displayed in the physical space. So I got really good responses from the design community after publishing the first version. Yeah, it was featured by some of the AR, VR media, and also, yeah, John Maeda tweeted my project. And one day I went to a local museum and found a beautiful empty space in the atrium. So I thought it would be exciting to play with some holographic objects. So again, with the type, I created this large-scale sculpture, layout, composition, and 3D. Then went back to museum and placed it and captured this video. So HoloLens provides this something called mixed reality capture, where you can capture the video of a first-person view with holographic objects. So yeah, as you can see, it's a really beautiful and amazing experience. As a designer, just being able to walk into the shower of the Helvetica was a kind of amazing experience for me. And yeah, it was also kind of interesting to see the relationship between these holographic object and the actual physical sculpture object in that space. Yeah, so yeah, this was a kind of mixed reality capture of it, and I could see some of the interesting articles about that project. Left one says unauthorized holographic sculpture placed at Belvedere Museum. And it was interesting to see the discussions around kind of privacy in this environment. People were kind of imagining the future of this kind of private public space and filled with all these kind of holographic objects. So just like a graffiti, just like a dystopian sci-fi movie. What about the future filled with all of these holographic graffitis? Who's gonna control it? So yeah, it was a kind of very interesting and relevant discussion. Then yeah, this one is the type timeline that I showed before, which I built with Adobe Flash before, but yeah, I brought that into Unity and just wanted to experience in actual 3D physical space and how it feels like. And I continued my experiments with type. This one is more try to experiment with dense text. So basically, your entire room is filled with this news headline. And as you can see, you can select the news provider and select the article to see the snippet. And because HoloLens has a relatively high resolution display when it compared to other VR devices, so it can really display this smaller or dense text, and still it secures kind of good readability, legibility. And this one is a kind of miniaturized version of it in the size of the kind of desktop app. So with hand tracking input in HoloLens 2, yeah, you can directly touch and grab and move and position the space. And this one is a kind of experiment with the VR. Yeah, again, with the same subject, the type. You can move around and observe and compare and play with the beautiful type and learn about their history, just like a museum situation. Then in 2019, HoloLens 2 was announced, and one of the biggest difference was it started supporting this hand tracking input, and also with the larger FOV, the field of view. So a lot of interesting interaction became possible. So yeah, this is a kind of example of a fully articulated hand tracking, which allows you directly touch and grab and play with interact with the holograms. And eye tracking is also supported so that you can use your eye movement to kind of control the content or target input. Yeah, as you can see, you can actually use the eye tracking movement to scroll up the text. And so this is a kind of more recent version of my project, Type in Space. So I updated to kind of support this hand tracking input for HoloLens 2. So now you can directly grab and move and lay out type in the physical space. And as you can see, with more improved spatial mapping, you can lay out type on physical surface. And I have added this kind of annotation capability, so you can grab and move anchors and place this kind of label on the top of physical space object. And in this version, I also started playing with the Asian characters. Just wanted to see and experience how this kind of dense stroke feels like in this mixed reality space. So yeah, as you can see, I've been playing with the Japanese, Chinese, and Korean, and also playing with physics. Yeah, it's not that practical, but it was fun to play with. Yeah, this is more large scale composition placed inside this large space. Yeah, playing with the physics. So yeah, if you experience in the actual device, it's a pretty amazing, magical, and overwhelming experience, especially if you love type. And yeah, this is a kind of example of playing with a Korean type with the spatial mapping. And yeah, playing with the different types of input, including system keyboard and voice command. And this is a kind of same app running on the VR device, so using motion controller. And with my personal interest in data visualization, I also I've been playing with this kind of public data. This is a kind of COVID-19 data, public data mapped on this 3D globe. And as you can see, you can, using hand tracking, you can grab and move and manipulate and observe the detailed data with this kind of text label in the 3D space. And yeah, I've been kind of writing design and development story on this personal project on Medium. So you can search a Medium like designing type in space for HoloLens 2 and other topics. So yeah, that was my quick story on my journey on type in mixed reality. And now I'd like to share some of the design considerations for type in mixed reality. So the first consideration is the nature of the transparent see-through display, such as HoloLens. So unlike a typical LCD screen, it uses the reflection of a laser and a micro mirror to form an image on the eye. So therefore, visual information is displayed through a laser in such a way called waveguide. And because of this reason, it has the characteristic of an additive display that consists of a sum of a light, unlike a general display. So in this additive display method, the brightest white becomes when RGB is the maximum power. But in case of black, with RGB equals 0, it is displayed as transparently. So this means that the black will be displayed as transparent. So therefore, colors can be displayed up to kind of dark gray, but technically pure black text cannot be displayed. However, if you display black text on the light background, like a white or bright yellow, then even if the text is transparent whole, it will visually appear as a black text unless it is very large. So yeah, because of that, you can see that white text is mainly used for HoloLens in or other see-through additive display devices. And there's another reason for using this kind of dark UI, the UI with a dark backplate and white text on it. As mentioned earlier, white is the strongest color displayed when the RGB laser is at its maximum. So large amount of white surface or object could cause eye fatigue. So the example on the right, if you experience that in the actual device, the white feels like a glowing light object, and it could make your eye get tired quickly. And another reason is, as you can see on this screen, when interacting with the device that supports hand tracking, such as HoloLens 2, then the white UI has a very strong color, so it covers a lot of your user's hand. It becomes almost like opaque plate. So that's that could be another reason. The biggest factor that affects the legibility of type in mixed reality is this property called pixels per degree, PPD. It's similar to PPI, pixels per inch, which is mainly used in 2D displays such as mobile and desktop, or DPI, which is used in print media. It's the number that can display how many pixels per unit area. So in displays where space becomes a canvas, such as augmented reality or virtual reality, the resolution can be measured by how many pixels can be displayed per angle. So as those of you who have used it will know, overall VR virtual reality headset has a fairly low PPD, so the pixels on the screen look quite rough and making it difficult to render text. So when working on VR apps, I tend to use a larger text size. And in case of HoloLens 2, it supports a resolution of 47 ppd, so text can be rendered relatively with a sharp and fine resolution. So because of that, when designing for mixed reality, it is necessary to consider the target device's hardware and resolution characteristics. So yeah, if you try some of the VR devices, this screen door effect is a kind of typical symptom with low-res displays. And yeah, you can also experience this kind of degraded resolution on the right side on the perimeter of your eye view. Then FOV, field of view, is also an important factor in AR or VR headset devices. It is a measure of how much information can be displayed in a field of view. And unlike PPD, which determines the quality of text, this number represents the viewing angle of the screen. So it will be an important factor in determining where to place the text or information in space. So as devices are constantly evolving, characteristics of such as kind of PPD and FOV are continuously improving. So we can expect that the text rendering quality will be gradually improved in mixed reality experiences. In terms of authoring tools for mixed reality experiences, game engines such as Unity and Unreal are most widely used. And however, there are some challenges around defining and communicating the type size and the unit because it involves many variables such as default unit of tool or scale of the containing objects or various text components that the game engine provides, and etc. So it is a little bit difficult to simply say what point size of the type is used. And so font size could become kind of random depending on the kind of scale of the object or containing object, and also with the kind of font asset generation options and methods. So when designing experience for mixed reality, we usually use metric unit for everything, for consistent communication and understanding of the space. So for example, there's a 10 by 10 by 10 centimeter cube object placed at 1.5 meter from the user, with the user's headset position. Then for near interactions that uses hand tracking, so objects like menu UI are usually placed at around 45 centimeter from the user. Then in Unity or Unreal uses this metric unit. So one Unity unit is 1 meter, for example. So defining and communicating type size in meter also makes sense and make it easy to design the spatial UI elements in mixed reality. So yeah, this is a kind of example of type RAM in HoloLens. And of course, proper type size depends on the distance from the user, just like the real-life object. So small text, such as a 6mm or 8mm size text, could be legible and useful for near interactions that happens around 45 centimeters. However, it'll be difficult to read them when they are on the object around 2 meter far interaction range. So it'll be important to consider the distance in physical and virtual space and consider techniques such as kind of angular scaling, which automatically scales up or down objects so that it can maintain the visual size regardless of the distance. Here's a kind of quick example from my personal project, Type in Space app. The hand menu UI has some text elements, labels that has a good legibility for this direct hand tracking interaction range, which is around 45 centimeter range. And this example shows a kind of angular scaling technique for menu UI. So as you can see, when the menu moves from near to far, it automatically scales up to maintain its readability and the usability by maintaining the usable button size. So as you can see, when the menu comes closer, it shrinks down automatically to kind of maintain this kind of proper size for different types of interactions. So in this case, direct hand interaction. So if you visit Microsoft Mixed Reality documentation, we have some guidelines on typography and the text size in Unity. So when creating a text in Unity, there are several options. Unity provides several text components such as 3D text, mesh text, and canvas UI text. And the problem is that by default, they're very blurry. So as you can see in the screen, so you need to tweak some of the properties such as scale to make the text sharp. And these days, a lot of mixed reality experiences use the new text component called Text Mesh Pro, which is now a part of the Unity. So it uses a technique called sign distance field to make the text always sharp and clear regardless of the distance and size. And yeah, these are some examples of the Text Mesh Pro component provided in Unity. And in selecting a font family or weight, it is generally recommended to avoid a font family with a thin stroke, such as a light or semi-light for augmented reality headset. The reason is that due to the characteristic of the display, in the case of a font which has too thin vertical strokes, that could make kind of that vertical stroke kind of shaking or a little bit blurry. So it kind of degrades the legibility. So in case of HoloLens, we recommend use the semi-bold or bold typeface family, and weights with kind of at least the regular thickness are used. And other than that, when selecting font for mixed reality, you can consider the same factors that are generally preferred in digital displays, like whether the contour opening is clear, X height is large enough, or the contrast of the glyphs are secured well. In case of HoloLens, we are using Microsoft official font Sego UI. And unfortunately, currently variable fonts are not supported by TextMesh Pro or Unity or other game engine components, because usually these software uses a generated texture from the font. So it is not like a real-time rendering of the font from the system. So yes, currently variable fonts are not supported yet. And in terms of a text input, HoloLens provides the system keyboard, which you can use your fingers and hand tracking to just directly type in, just like a physical keyboard. And it also supports voice input as well. And it also supports swipe input as well, which allows you swipe between the characters to construct the words. And of course, even with the hand tracking input, it could be still difficult to type in long text. So in this case, you can use a dictation as well. So this is for my personal project, the Typing Space app, which uses speech input and dictation for long text input. And billboarding is a kind of interesting technique for object and mixed reality. It makes object always face you regardless of your position. So using this, you can make the text automatically rotate and face you toward you, which makes the text always easy to read wherever you are at. And this is not specific to text in mixed reality, but in general, this head-up display HUD is not recommended when in mixed reality. This is a kind of popular pattern in sci-fi movies, which displays the text and graphical information around your eyes. It looks great on movies and games when you use a TV or PC monitor, but when you experience this in mixed reality headset, soon you will realize that these visual objects around you stuck to your head movement are very annoying and causing fatigue, and it makes you want to remove them by shaking your head. So in mixed reality, it is recommended to make these information stay around you with some kind of delayed movement, which we call tag-along. So HUD style display could be still useful for certain contexts, but it is better to kind of minimize the amount of the information around your eyes. So lastly, I'd like to share some of the tools and resources information for building mixed reality experiences. So for those of you who are not familiar with MRTK, Mixed Reality Toolkit, MRTK is an open source project by Microsoft where we provide foundational components and the building blocks for common spatial interactions and UI. So if you look at some of the components in MRTK, with Object Manipulator, you can grab and move and rotate, manipulate object with one hand or two hands, and also it supports near and far interactions. Then with Bounding Box, the bounds control is a standard interface for scaling and rotating 3D object in mixed reality. And MRTK provides various types of UI that supports hand tracking input, like buttons and toggle switches, checkbox. And hand menu is one of the most popular UX pattern in HoloLens 2, which you can attach the menu to the hand so you can quickly bring up and do a quick action and hide it when it's done. And yet MRTK has a tooltip components, which you can use for annotation on 3D objects. And spatial mapping and spatial awareness provides the capability of being able to place an object on the surface. And MRTK provides standard shader, which is optimized for this HoloLens mobile CPU and GPU, and provides a beautiful visual effects that are necessary for spatial interactions. And other UI components like a slider and the near menu, which is a kind of floating menu around you, easily accessible, and you can also make it word locked by grabbing and placing it, and also automatically follows you on a certain distance. And scrolling object collection, kind of scrolling list of 3D or 2D contents that supports hand tracking. And slate, displaying the 2D content in 3D space, like images and schematics, and provides this kind of grabbable window and also tag along option. And other components like hand coach, which is a kind of teaching component for gestures, and various types of eye tracking examples. Using eye tracking input, you can control the movement of the content, automatic scroll of the text based on your eye position, and heat map example that shows how and where users are looking at. So we have a MRTK for Unity and Unreal, and for both game engines, we provide these crucial spatial and UI building blocks for mixed reality. And if you look at one component, the button, which is one of the most foundational elements, and in mixed reality, because there's no physical feedback, it is quite important to provide enough visual and audio feedback. And if you look at this example, it has a lot of details like lighting effect, proximity light that based on the distance from the fingertip to the target surface, and the compressing button effect, and the pulse effect based on the moment when the event is actually triggered. So all of these are kind of combined together to improve the quality of the interaction and confidence. So if you use MRTK's building blocks, so you can get all of these rich visual and audio feedback, which is a kind of result of our design and research iterations for a long time. And yeah, this is an example of the button structure, the prefab provided in MRTK. And there are useful documentations. If you go to aka.ms/mrdocs, there's a general mixed reality documentation on including design guidelines. So if you go into this design section, there are several getting started documents which introduces some of the core concepts and interaction design and UX elements. And some of these are example of the UX building blocks. For example, this is a guideline for hand menu where we provide some of the learnings and prototypes we did. Yeah, so that was a kind of quick intro to my journey on personal project in mixed reality and experiments in type in physical space, and also introduce some of the design considerations and tools and resources for mixed reality. I hope it was helpful and give you some good insight, and I hope you can see in mixed reality. Thank you very much.
Excellent stuff. Thanks so much for sharing it. How are you doing?
Thank you. Yeah, thank you so much for inviting. Yeah.
Yeah, you're most welcome. Does anybody in the audience have any questions?
You guys can type them in the chat, or you can type them in the Q&A. Either way, we will see them, we will read them, and then that is how they get answered.
Yeah, I just wanted to share one thing. If you're looking at a lot of videos in my presentation, maybe some of you are wondering why the hands are rendered on top below that UI when you press the button or UI. Yeah, that is because of some of the limitation of the capture capability, also limitation for kind of masking hand. So yeah, actually when you're interacting with the UI in the HoloLens, your hand is actually on top of the UI. Yeah.
Also, now the masking works correctly?
Yeah, and
Okay.
so yeah, you can mask the hand mesh and make it work, but there's a little bit of a limitation, and because of the hand tracking sensor's latency, so
Right.
it doesn't feel like a very natural, and also as I mentioned, all these kind of graphical elements in HoloLens is a kind of additive display element, so it's quite bright, and so when you mask your hand mesh, it's a contrast between your actual skin versus that graphical elements is quite strong. So we thought it's a little bit too much and it doesn't feel natural. So for our OS level, we turned it off, but as a developer and content creator, you can definitely enable it. Yep.
Mm.
There's one question that's asking, how did you judge type size that is 0.2 millimeter?
Yeah, so yeah, personally, I've been kind of trying to understand, as I mentioned, a lot of most of the developers and creators are using either Unity or Unreal to create this AR and VR app. And the problem is yeah, it's all in metrics, all the units, and even for the type components itself, there's no kind of really kind of solid definition of type size. It's all over the place. And when it also kind of involves in kind of scaling of the container, then it becomes more complex. So I've been trying to kind of map how understand how this kind of our point-based type size map to this kind of metric system in the physical space. And I've been kind of printing out and placing the 1 meter and trying to overlay with the holographic type on top of that and trying to compare. But yeah, now in Unity, as I mentioned, now people are using something called Text Mesh Pro, which is kind of it provides really great quality regardless of distance and size. So we are using that, and yeah, because of that, we've been kind of as a design team also we were just using metrics to kind of understand, yeah, in this specific distance, this kind of type size of millimeter works well, and we've been actually not haven't been thinking about that kind of 0.2 millimeter conversion that much, because we kind of when you design something, we just start uh, from that thinking, just let's use a millimeter and metric system just to make it easy to from the beginning, from the design phase. Yeah, and we've been also when you design a UI, like you can also use kind of a lot of 2D tools like a Figma. Then so we've been using Figma a lot, and we've been also trying to understand how to kind of map this kind of size from Figma to this kind of Unity or Unreal tool. Yeah, still trying to optimize those kind of flow, but in our design team, we are trying to use just start everything from the metric system. Just to make it easier. Yeah.
Nice. I think there's one more question from Steve. He says, sorry, basic question. Video captured from visor is all in focus. Is this how the user experiences it, or is there a depth of field / peripheral blurring? If all in focus, does this add to the fatigue?
Oh, I see. Yeah, it's the captured image is a little bit different from actual experience, but because this device essentially is just it's just like a glass. So there's no real kind of additional rendering or post processing for actual physical environment. So there's nothing like that, and only the device kind of displays the digital graphics on top of your eyes, on top of physical world. So uh, yeah, those kind of I think a depth of field and blurring, those kind of techniques can be only applied to that, the graphical element, that this digital content that are displayed by that laser. Then um, yeah, technically, I think it is possible to apply those kind of more artificial kind of blurring or degraded the rendering based on the distance, and also there have been kind of research around that to uh,
improve the overall performance, because these are kind of mobile device and mobile GPUs. So if you want to render complex and object or higher resolution content, then you want to kind of minimize the rendering for based on the distance, or if you based on the peripheral. So that kind of things are happening, but in general, I think we are not using those kind of depth of field or other techniques to kind of differentiate field of different depth. And it's you can think it's just like a real life physical object. You don't really kind of do any additional kind of modification or rendering of these different object in different distance. But if you just focus, just like a physical object, if you focus on the object in the near, then it really kind of depends on your eye. It's not like applying artificial kind of drawing to digital object. But definitely it is possible, I think. And sorry, additional question was fatigue. I don't think there's a eye fatigue or things like that because of that. But obviously, the one problem I saw was I think it's also kind of similar to physical object. But when you display some object in the near distance and some object in further distance, and when you switch between near and far, then definitely it causes a lot of change of the focal distance, then it'll definitely cause eye fatigue. And because of this additive display characteristic, if the content is too bright, and it means like a laser that kind of maximum power and make your eye fatigue. Like if you look at quite bright object too long time, like an hour or something, then definitely I can imagine fatigue issue.
There's another question on is there OpenType feature support in the tools, and did you use OpenType features in your application on HoloLens?
Yeah, that's the thing. Yeah, unfortunately, as I mentioned, Unity and Unreal, a lot of game engines, they are using the kind of texture output generated from the font. So the engines are not accessing the font directly. So not like a Windows or Mac accessing the system font. So that's a kind of very big limitation currently. So we cannot use any great goodness of the variable font or OpenType features. I want to see how the Unity or Unreal and game engine companies can evolve this kind of font system. But for now, I think that's a kind of big limitation. Basically, there's a kind of inside Unity or Unreal, there's a conversion tool, and which kind of we can specify the kind of resolution and type size, but eventually that once that textures are generated, then you are kind of stuck to the texture set of the font.
Is there anything in the works to allow for real type use, or are you guys do them directly?
Not sure. I think I think I said really depends on the Unity side or Unreal, like a game engine companies.
But it seems like if they're pre-rasterizing, maybe let's say there is a paragraph that you want to show and you're pre-rasterizing it. The tool that does the pre-rasterization, does that support shaping or complex shaping?
Not sure.
Because it'll be interesting to see how like complex script support in environments like this looks like. So if you want to display some of the indic scripts or something like that.
Right. Yeah, definitely you can specify the kind of the texture size. So definitely you can make texture size super big, like 5K by 5K. Then I think that will definitely improve the kind of resolution of the individual glyphs, and especially the language with the kind of dense complex strokes. But I think still it's once it is generated, I think I fixed that.
Cool. All right. Any more questions? Okay. I think that's it.
Thank you so much. Thank you, everyone.
Thank you so much for being here.